Hi students, okay, today we are learning the topic is general solution of higher order ordinary linear differential equation. So higher order lo two types differential equation, that is only non-homogeneous equation and homogeneous equation. So there is operator form of the higher order differential equation is f of d into y is equal to q of x, where f of d is a polynomial in capital D of nth degree, where capital D is a d by dx form. Okay, now this is a first of all we have to finding the general solution of homogeneous equation. Homogeneous means when the equation when q of x is equal to 0, that is equal to f of d into y is equal to 0. Okay, na? Okay, first of all see that here the general solution of the given equation homogeneous, where f of d is equal to d power n plus p1 into d power n minus 1 plus p2 into d power n minus 2 plus up to so on pn. So its solution is called complementary function, and it's given by y is equal to yc is equal to c1 y1 plus c2 y2 plus up to so on cn yn, where y1 y2 up to so on yn are linearly independent solutions of the given equation. And nth order కాబట్టి there exist n arbitrary solutions. So in case second order only 2 solutions, third order 3 solutions. So the totally complete general solution is the linear combination of all independent solutions, that is called a general solution of the given homogeneous equation. Okay, now where c1 c2 up to so on are arbitrary constants. So this is a solution. Then how to finding this solution? So you are given some formulas, and this solution is depend on the roots of auxiliary equation. See the definition of auxiliary equation is, so that is equal to an algebraic equation f of m is equal to m power n plus p1 into m power n minus 1 plus p2 into m power n minus 2 plus up to so on pn minus 1 into m plus pn is equal to 0. And this is equation is obtained from in the given equation f of d into y is equal 0 kada, and f of d place lo d replacing andi, so equating 0, that is called an algebraic equation. This equation is called auxiliary equation, where p1 p2 up to so on pn are real constants. Okay, na? So this is the nth degree polynomial equation. Now solving this equation we getting n roots. So to nth degree, so n roots exist. So their roots are 4 types are given. So that is equal to here. Let n roots are m1 m2 up to so on mn. There are 4 types or equations of solutions. So first one is real and distinct roots, and second one is real and some equal roots. Third one is real and complex roots. Fourth one real and irrotational roots. And totally the solution of the given homogeneous equation depend on the these roots of auxiliary equation. In 4 cases 4 types of solutions. And so okay, see the formulas are given how to finding the solution of the homogeneous equation in 4 cases. Okay, so that is the general solution of the homogeneous equation is depends on the roots of auxiliary equation. Okay, na? So that is equal case 1 if the roots are real roots and distinct. So assumption here m1 m2 up to so on mn are real and distinct roots and of auxiliary equation f of m is equal to 0. So therefore general solution is, that is complementary function of f of d into y is equal to 0 is, so y is equal to yc c1 into e4 m1x plus c2 into e4 m2x plus up to so on cn into e power mnx. And direct finding the roots are substituting here. Chudandi e4 m1x, this is m1 root, e4 m2x m2 roots up to so on mn roots. This is the solution of homogeneous equation when the roots are real and distinct. Okay, na? Similarly case 2 if the roots are real and some equal roots. Some equal roots means maybe 2 roots are equal, 3 roots are equal, or up to so on all roots are equal, and also 2 roots are equal maybe. So in again special cases, then finding the solution is first one First two roots are equal. M1 is equal to M2. Remaining are distinct. The solution is given by, so y is equal to yc is equal to c1 plus c2x అండి. Two roots are equal to what? This formula is c1 plus c2x into e power m1x plus remaining all distinct. So using the case 1 here. Okay na? Next maybe three roots are equal. M1, M2, M3. Three roots equal, remaining are distinct. So yc is equal to here c1 plus c2x plus c3x square into e power m1x plus remaining distinct. So maybe two roots are up to so on all roots are equal, and in case n roots are equal, the solution is given by yc is equal to c1 plus c2x plus c3x square plus up to so on cn x power n minus 1 into e power m1x. This is the solution, all roots. In case two roots are equal, and m1 is equal m2 and m3 is equal m4. First two roots equal and second different two roots are equal, remaining may be distinct. Then the solution is given by y is equal to yc is equal to c1 plus c2x into e power m1x plus remaining are two roots are equal, that is c3 plus c4x into e power m3x plus up to so on, remaining are distinct. So this is the case 2 అండి. So the number of roots is equal to the number of constants, must be equal ఉండాలండి. The number of roots is equal to the number of arbitrary constants. This is a case 2. So this is a direct formulas and directly finding the roots, directly substituting here in this formula, we getting the general solution, that is complementary function of homogeneous equation. Next case 3. So case 3, if the roots are real and complex roots. Complex roots means a plus ib. A plus ib is a complex roots and its conjugate is also root, and a minus ib is also root, that is a plus or minus ib root. Two roots and so here first case 1 again, if a plus or minus ib the complex roots, remaining real roots, then the solution is yc is equal to e power ax into c1 cos bx plus c2 sin bx అండి. ఇక్కడ a plus or minus ib అంటే టూ రూట్స్, ఇక్కడ m1 m2 అండి. సో ఇక్కడ e power ax ఇక్కడ a వాల్యూ, b అంటే b వాల్యూ, ఇక్కడ b సబ్స్టిట్యూటింగ్ ప్లస్ రిమైనింగ్ ఆర్ రియల్ అండ్ డిస్టింక్ట్ ఆర్ ఈక్వల్ యూజింగ్ case 1 or case 2. Okay na? So next one, two roots are complex roots. First pair is a complex, second pair is also complex. ఇక్కడ m1 m2, this is m2 m3, all are complex, remaining may be real and distinct or equal. Same, yc is equal to first pair is complex, e power a1x c1 cos b1x plus c2 sin b1x plus second pair is also complex, that is equal to e power a2x plus into c3 cos b2x plus c4 sin b2x plus up to so on, remaining are real and distinct. So in case two roots are equal and complex roots also may be equal, first pair and second pair is also complex and same, then the solution is y is equal to yc is equal to e power ax into c1 plus c2x equal కాబట్టి. So equal roots కాబట్టి using case 1 same procedure. So c1 plus c2x into cos bx plus c3 plus c4x into sin bx. ఇక్కడ 4 roots 4 constants and remaining may be real and distinct using case 1 case 2 here. Okay, so this is case 3. Next case 4, if the roots are real and irrotational roots. Irrotational roots means the form of the root a plus root b. A plus root b is the irrotational roots and its conjugate is also root, that is a minus root b. And a plus or minus root b is the irrotational roots, that is equal to here a plus or minus root b, remaining are may be real and distinct or equal or complex, may be అలాగే ఉండొచ్చు remaining roots. So this is m1 m2 అండి. a plus or minus root b is the m1 m2 two roots. The solution is given by e power ax ఇక్కడ a value into c1 cos hx root b plus c2 sin hx root b plus up to so on, may be real roots are any using here case 1 case 2 case 3. Okay na? So ఇక్కడ cos hx and hyperbolic తీసుకుంటాం, అదే కాంప్లెక్స్ ఇస్తే జనరల్ ఫంక్షన్ cos bx sin bx. సో ఈ రొటేషన్కి హైపర్బోలిక్ ఫంక్షన్, ఇక్కడ a వాల్యూ సబ్స్టిట్యూటింగ్, ఇక్కడ b వాల్యూ సబ్స్టిట్యూటింగ్. So this is a case 4. This is 4 cases, using to finding the solution of the homogeneous equation f of d into y is equal to 0. Okay. Yeah, see the example problems on homogeneous equation. So first solve d square y by dx square minus 4y is equal 0. This is the second order ordinary linear differential equation with the constant coefficient. First we write the operator form. So that is equal to operator form is d by dx means d gada, capital D. There is the second order, so d square y minus 4y is equal to 0, where d is equal to d by dx. So this is operator form is y common, d square minus 4 into y is equal to 0. Which form is f of d into y is equal to 0. This is a homogeneous equation form only. This is a q of x is equal to 0. This is a homogeneous equation where f of d is equal to polynomial d square minus 4. This is f of d only, d square minus 4. So now taking auxiliary equation is m square minus 4 is equal to 0. Now finding the roots. So m is equal to plus or minus 2 only. So 2 minus 2 both are real and distinct roots. m1 is equal to m2 is equal to minus 2. So m1 m2 real and distinct using the formula. So formula is only two roots together, only two arbitrary constants. So c1 into e4 m1x plus c2 e4 m2x, that is equal m1 is equal to m2 is equal to minus 2, substituting here. So y is equal to yc is equal to c1 e4 2x plus c2 into e4 minus 2x. So this is the general solution of the homogeneous equation depend on the roots of auxiliary equation. Okay. Okay, second equation is, this is third degree children, third order linear differential equation. First write the operator form. So there is operator form is d cube minus 3d square plus 3d minus 1 into y is equal to 0. So this is form is f of d into y is equal to 0. F of d into y is equal to 0, where f of d is equal to d cube minus 3d square plus 3d minus 1. Take the auxiliary equation. So f of m is equal to 0 kada. And f of d place lo m replacing. That is m cube minus 3m square plus 3m minus 1 is equal to 0. This is third degree polynomial equation. Now finding the roots. So the roots are, which form is a minus b whole cube form, and a is equal to m, b is equal to 1. That is m minus 1 whole cube is equal to 0. So m is equal to roots. Three roots are equal. 1, 1, 1. 1, 1, 1 is a three real and equal roots. And three roots are equal. That is the formula is m1, m2, m3 equal. And so c1 plus c2x plus c3x square into e4 m1x. So this is the three roots are equal, three arbitrary constants c1, c2, c3. Substituting m1 is equal to here 1. That is equal to c1 plus c2x plus c3x square into e4x. This is the solution of given homogeneous equation. Okay, that is equal. Next example, y triple dash minus 3y dash plus 2y is equal to 0. So that is equal to, write the operator form. So this is a third order linear equation. So operator form, y double dash means d cube minus 3d plus 2 into y is equal to 0. This is operator form, f of d into y is equal to 0, where f of d is equal to d cube minus 3d plus 2. Take the auxiliary equation. F of m is equal to 0, that is m cube minus 3m plus 2 is equal to 0. Find the roots here. Yeah, m is equal to 1 is the first root. Okay, now remaining by using the synthetic division or the procedure, dividing by 1 the coefficients of the given equation, we getting the second one, m square plus m minus 2 is equal to 0. The roots are m is equal to 1, here roots 1 minus 2. So that is equal, the roots are 1 1 minus 2. అంటే 2 roots are real and equal, remaining third root distinct. అవునా, ఇది m1 m2 ఈక్వల్ అండి, m3 is the distinct. So the solution is given by, so c1 plus c2x into e4 m1x. ఇది ఈక్వల్ రూట్స్, 2 roots are equal, c1 plus c2x remaining distinct. Substituting m1 is equal to 1, m3 is equal to minus 2. That is equal to c1 plus c2x into e4x plus c3 into e power minus 2x. Okay, this is the solution of the given homogeneous equation. So next one, okay, find the complementary function of d square plus d plus 1 into y is equal to 0. అంటే కాంప్లిమెంటరీ ఫంక్షన్ అనేది కూడా సొల్యూషన్ ఆఫ్ ది హోమోజీనియస్ ఈక్వేషన్, బోత్ ఆర్ సేమ్. సో దట్ ఈస్ ఈక్వల్ టు గివెన్ ఆపరేటర్ ఫార్మ్ ఇస్ f of d into y is equal to 0. సో వేర్ f of d is equal to d square plus d plus 1. అవునా, auxiliary equation is f of m is equal to 0, that is m square plus m plus 1 is equal to 0. So find the roots here. There is no real roots. Using the formula is, we getting the roots using the formula undi manaki, minus v plus or minus square root of b square minus 4ac by 2a. Using that formula we have to finding the roots. Their roots are minus 1 plus or minus root of 1 minus 4 by 2, that is equal to minus 1 by 2 plus or minus I root 3 by 2. This is the complex roots only. The two roots are complex, that is equal to form a plus or minus ib. Here a is equal to minus 1 by 2, b is equal to root 3 by 2. So formula is equal to, solution is yc is equal to e power ax into c1 cos bx plus c2 sin bx. This is formula for complex roots and a plus or minus ib. Here a is equal to b is equal to substituting, that is equal to here yc is equal to e power a is equal to minus 1 by 2x, c1 into cos b is equal to root 3 by 2x plus c2 sin root 3 by 2x. Okay, this is a solution of given homogeneous equation. Okay, next one, solve d cube minus 14d plus 8 into y is equal to 0. That is equal to, given direct operator form is f of d into y is equal to 0, where f of d is equal to d cube minus 14d plus 8. So auxiliary equation is m cube minus 14m plus 8 is equal to 0. d plus lo m replacing. So that is equal to, find the roots. The first root is m is equal to minus 4 and by using inspection and directly substituting m is equal to 1, m is equal to minus 1, m is equal to 2, m is equal to minus 2 up to so on. Which one is satisfying? That is the first required root and so ఇక్కడ m is equal to minus 4, the first root satisfying. So remaining finding, dividing by minus 4 the coefficients of the given equation. We getting the second equation, m square minus 4m plus 2 is equal to 0. Finding the root, this one. So this second equation roots are getting the complex roots and so or anyone, that is equal to, we getting the rotational roots, minus b plus or minus square root of b square minus 4ac by 2a. Using that formula we getting the roots are 2 plus or minus root 2. So 2 plus or minus root 2 means is irrotational roots, a plus or minus root b and if first root is a real and distinct, remaining two roots are irrotational roots. That is equal to minus 4 comma 2 plus or minus root 2. Therefore solution is y is equal to, yc is equal to c1 e power m1x. Remaining roots are a plus or minus root b form, e power ax into c2 into cos hx root b plus sin 3 c3 into sin x sin hx root b. Substituting a b value, c1 into e power minus 4x plus e power 2x, a is equal to 2 no? into c2 into cos hx root b ante root 2 plus c3 into sin hx root 2. This is the solution of given equation. Okay, see the next question. Write the complementary function when the auxiliary equation have the roots 2 plus 3i and 3 minus 2i. And you are given directly roots only. In the previous question low to finding the roots, next to finding the solution. But here already given the roots only. Directly write the solution of the given equation. That is a complementary function means solution of the homogeneous equation. So observing here, what are the roots here? 2 plus 3i. These are complex roots. Only one root are given. Its complex conjugate is also root kada. Ante 2 minus 3i is also root. Next to 3 minus 2i root. Ante this conjugate is also root. 3 plus 2i. Ante that is equal to here 2 pairs of complex roots are given. Ante m1, m2, m3, m4. That is equal to here. So that is equal to therefore the required roots are 2 plus or minus 3i and 3 plus or minus 2i. This is a complex roots. This is a complex roots. Okay na? So this is a1 plus or minus b1i. This is a2 plus or minus b2. So therefore the complementary function is, this is the first pair complex roots. This is the second pair complex roots. Substituting here a1 2, b1 3. Next one a2 is equal to 3, b2 is equal to 2. That is equal to directly substituting. Y is equal to yc is equal to e power 2x into c1 cos 3x plus c2 sin 3x plus this is e power 3x into c3 cos 2x plus c4 sin 2x. 4 roots, 4 arbitrary constants. So this is the solution of the given. Yeah, see the next example here. D square plus 1 whole square into y is equal to 0. So given equation, that is f of d into y is equal to 0, where f of d is equal to d square plus 1 whole square. So that is equal to m square plus 1 whole square is equal to 0. So here m square plus 1 whole square means 2 times. That is m square plus 1 is equal to 0 and m square plus 1 is equal to 0. M is equal to here root plus or minus I plus or minus I. And 4 roots are 2 pairs is a complex. That is 2 pairs also equal. Plus or minus I plus or minus. Which form here? A plus or minus IB together. A is equal to 0, B is equal to 1 here. Equal roots. That is 0 plus or minus I1 and 0 plus or minus I1. That is equal. Solution is, so both complex roots are equal. So e power ax into c1 plus c2x cos bx plus c3 plus c4x into sin bx. A is equal to 0 and b is equal to 1, substituting here. That is equal e power 0 into 1. So c1 plus c2x into cos x plus c3 plus c4x into sin x. This is the solution of the given equation. So totally every problem same only. Only finding the roots. The roots are define the 4 cases, using that any case substituting directly in the solution. This is solution of homogeneous equation. Okay, see the next one. So given equation is second order equation, y double dash plus y dash minus 2y is equal to 0, and also given initial conditions, y of 0 is equal to 4, y dash of 0 is equal to 1. Okay, that is using the second order given two initial condition, y of 0 and y dash of 0. First to finding the solution, next to finding using this initial condition, we have to finding the values of arbitrary constant, that is c1 c2 and finally finding particular solution of the given equation. First to finding the general solution, same procedure, this operator form, d square plus d minus 2 into y is equal to 0, that is f of d into y is equal to 0. So therefore auxiliary equation is m square plus m minus 2 is equal to 0. The roots are m is equal to 1 comma minus 2. Therefore solution is yc is equal to c1 e power x plus c2 e power minus 2x. Real and distinct together. m1 m2. So this is a general solution. Now using the given initial conditions, now finding the C1, C2 values. So substituting, now differentiating equation 2, because y of 0, y dash of 0 kada. Now differentiating of solution, y dash of x is equal to C1 into e power x derivative e power x, e power minus 2x derivative minus 2 into e power minus 2x. Okay na? That is equal to given initial conditions. First one, y of 0 is equal to 4, y dash of 0 is equal to 1. So substituting in equation 2, from equation 2 substituting x is equal to 0, y is equal to 4 and that is equal to y of 0 kada. Y of 0 ante 4. Ikkada e power 0 1, c1 plus e power 0 2 ante c1 plus c2 is equal to 4. Next from equation 3 substituting the second condition. This y dash of x kada. X is equal to 0, y dash of 0 is equal to 1. That is equal to c1 minus 2c2 is equal to 1. Now solving equation 4 and 5. Now solving equation 4 and 5, we getting the c1 value 3, c2 value is equal to 1. This is the particular values. Substituting in equation 2. Therefore the final solution is y of x is equal to yc is equal to 3 e power x plus e power minus 2x. This is a particular solution of the given homogeneous equation. So that is a given using the initial conditions to finding the C1 and C2 values. Okay. Yeah, thank you. So this lecture is to find out solution of the homogeneous equation. This total solution depend on the roots of auxiliary equations. Okay. For more videos, please do subscribe my channel, like and share. Thank you.